Okay, so we're here in the front yard and I'm going to demonstrate an object flipping around an axis. Then we'll calculate its moment of inertia using two different methods. So we'll have to be quick about this because it's raining, but pay attention. Okay, so that was an object spinning around an axis. So now we're going to go back inside and calculate moment of inertia using the rod approximation around the end and using the parallel axis theorem. So now we're going to calculate moment of inertia for that situation. So we're going to approximate my body as a rod that is flipping around an axis. So here's the axis, and I am a rod of length L. Then we need to know the mass. So given mass and length of the rod, find, say this axis is A, I around A, using two different methods. So first method is rod around end. Which is that formula. Second is parallel axis theorem. Which in this case is the rod around its center plus this distance, which we know is L over 2. So for situation 1, the rod around its end, we know that moment of inertia should be I equals m L squared times 1/3. For the second situation, we know that for a rod around its center, we'll have that IC, and then this is the axis. So we need this distance, which is L over 2. And we have to add those two moment of inertias together. So I equals that IC plus mass times distance squared. So for some numbers, my mass is 55 kilograms. And length, say with arms extended, length comes out to be 2 meters. So now we'll work the problem both ways and make sure that we get the same answer. So for the first one, we'll have 55 times 2 squared times 1/3, which equals 73.3 units are kilograms for the mass times meters squared for that distance. Now for the parallel axis theorem, for this we will have moment of inertia around the center, which is 1/12 m L squared plus m times the d squared, and in this case, distance from the center of mass to this axis of rotation is half of the length. So m times L over 2 squared. So this is 1/12 times 55 times 2 squared plus 55 times L over 2, which is just going to be 1 squared. That is 18.3 plus 55 equals 73.3 kilograms times meters squared. So that is moment of inertia, and we verify that they both equal the same thing. We can also look at this. If we were to just work this out completely in variables, we would see that parallel axis theorem simplifies down to the same formula for the rod around at the end. That's actually how they got it. So we take this parallel axis theorem one, so we'll have I equals 1/12 m L squared plus m L over 2 squared equals m L squared times 1/12 plus 1/4 equals m L squared times 1/3. So if we work it out in variables, we get the exact same formula.